Good morning, good evening, everyone. Welcome to another session hosted on behalf of the Azure Cloud Commanders user group. But today we've got Wolfgang Offner coming to present on mastering the Kubernetes Gateway API. So really looking forward to this. Thank you and welcome. Before we get going, just a couple of housekeeping rules. So the Azure Cloud Commanders is part of the Microsoft Learn Skilling Room. So if you go to the Microsoft Tech community, go under Skills Hub, Skilling Room directory, you'll see a bunch of learning rooms, such as the Azure Cloud Commanders, where we talk about Azure stuff. We've got discussions going and we host events like this. So yeah, the community can learn from the community. It's great. So feel free to check that out. Hopefully that's how you've come across this session. But regardless, we're all here to hopefully learn something. People come from different backgrounds. So yeah, just have fun. I'll be monitoring the chat throughout. So feel free to ask any questions and I'll interrupt our presenter today and we'll hopefully get those answered for you. With that, I will hand it over. So I'll switch the screens around just like magic. And yeah, feel free to introduce yourself a bit better than I have, and really looking forward to this session. Thank you.
All right, thanks. Welcome everyone to my session about the Kubernetes Gateway API. So the plan for today is I'm going to give you an introduction what the Gateway API is, and also how it compares to Ingress. So first, we're going to take a look at how we can expose our pods in Kubernetes. This means how we can access our applications from outside our cluster, and this will lead us to the Gateway API. Then we take a look at a couple of the capabilities, for example, the routing. I give you an overview of the differences between the Gateway API and the Ingress, and also my personal opinion. Then we are going to take a very quick look at a couple of gateway controllers that are out there. And then I'm going to show you a demo about everything I showed you in theory. If you're interested in the slides or in the code examples from today, you can scan this QR code and you'll find everything on my GitHub repository. Before I get started, a couple sentences about myself. My name is Wolfgang Offner. I'm a freelance cloud architect. I'm based in Toronto, Canada. I'm a Microsoft Azure MVP, and I focus on everything with Azure, but also Kubernetes and DevOps. If you're interested in these topics, you can find many blog posts on my website or also videos on my YouTube channel. If you have any questions after the session, feel free to reach out on LinkedIn. That's probably the easiest way. Or I'll be back next week for kind of a second part to this Gateway API series. But now let's get started. First, let's talk about how we can expose our pods. So just as a quick reminder, a pod is the smallest type we have in our Kubernetes cluster. And to simplify a bit, you can say a pod is a container and it contains our application. And we have different options to expose this application to the outside world. The first one would be to use a Kubernetes service of type load balancer. This makes it accessible to outside the cluster. And if you're using a cloud provider like Azure, AWS, GCP, then you get a public IP address attached to this service. This means I can access my application over the internet with this public IP address. The downside is I don't have any production features I would like to have. Like I don't want to access my application with an IP. I want to have a DNS. I want to have some routing rules, maybe some monitoring. And this leads us to the Ingress. The Ingress or Ingress controller has been introduced with the Kubernetes version 1.1. So it's a very old feature. And it's a single entry point to our cluster. And then it redirects or routes our requests to the right service and therefore to our application. And having this one entry point has a lot of advantages. For example, I only need one public IP address where I can have all my DNS records pointing to. I can have monitoring what's going on. I can have different routing options and everything I want to have in my production environment. But the ingress comes with a couple downsides, which we're going to see later. And this is why the Gateway API has been introduced. The Gateway API went GA around 3 years ago, so it's still fairly new. And it tries to fix the downsides of the ingress controller, but it functions more or less the same. So we still have one entry point. We can do routing. We can have TLS certificates. We can have monitoring. So yeah, so now let's take a look at that. I think I was too slow with my slides. I already said this with the ingress and the Gateway API. We have one entry point into our cluster. This makes it very easy to manage the entry, and it also allows all our services of type cluster IP. This means they are not accessible from outside the cluster except through this ingress or Gateway API. This makes it easier to manage DNS records and also keeps them secure because we only forward requests we want to forward. Then with this one central entry point, we also have better routing. We're going to see later in the demo how we can route our traffic. This can be based, for example, on a different URL, but also on a path or a header. This means I can have an online shop, and if I call my online shop with the URL /admin, I route my request to another application that's maybe more secured than my online shop. Or I can have two different services. One serves my desktop application, and the second one serves an application for mobile phones. So I can decide which version I want to serve depending on the device the user is using. Then I can use the Cert Matcher. That's an open source tool. And with this, I can automatically create TLS certificates and attach them to the ingress or the Gateway API. This means I can call my services or my URLs with HTTPS, and I have a fully valid TLS certificate. This is what I'm going to show you next week. There we're going to set up how these automated TLS certificates work, and we'll also see that they will be renewed automatically. So once we have set this up, we don't have to worry about expiring certificates, and we can access our cluster and our application with HTTPS. This also includes TLS termination. This means we have HTTPS from our device to the ingress or the Gateway API, and from then on, we have HTTP on port 80 to reach our application. This means we don't have to change anything in our applications, but we still have a secure connection. With ingress, as I said, it was introduced in version 1.1, so that's around 10 years ago, and therefore we have a vast ecosystem, and so we have a whole bunch of ingress controller. The most popular ones are probably Traffic, Nginx. So these are two open source controller which are running inside the cluster. And if you're using, for example, Azure or any other cloud provider, they have their own service. In Azure, we have the Application Gateway Ingress Controller. That's an Azure service that runs outside the cluster. This means all the processing is done outside the cluster. Therefore, you don't need any resources. You have some additional features, but the downside is you have to pay for it. And it also makes everything a little bit more complicated because you have one additional service. And now let's talk about the downsides, because I think there are quite a couple, and this makes it hard to, I think, to learn Ingress, or at least for me, it was a bit hard to understand how it works in the beginning. And the first problem is that the Ingress controller has the full control over basically everything. So for example, if you're using Nginx, it's a reverse proxy, and you have one config file where you have all the routing defined. This means if you have a big cluster, this routing file can be hundreds or thousands of lines of code. If you change something and you mess it up, it's possible that nothing works anymore because everything is inside this one file. Then, in my opinion, probably one of the biggest downsides is that Ingress uses annotations. This means you set annotations on your application and you tell it what to do or what Ingress to use. For example, if I'm using Nginx, I set on my application that my Ingress class is Nginx. And this makes it very difficult to change ingress controller. This means I have kind of a vendor login. And if I want to switch, let's say from Nginx to Traffic, I have to change probably everything or all my applications and redeploy them. Then what's also a bit annoying is we don't have any cross namespace support. This means all our TLS secrets need to be in the same namespace as our ingress. It's not the biggest problem, but if you have a bigger cluster and multiple teams, it might be nicer to separate everything, give different permissions, and with ingress, that's unfortunately not possible. Then there are more downsides. The next one's not such a big deal, I think, is that ingress doesn't support traffic policies. So for example, you can't configure what backends are allowed to talk with each other. There are many other tools, so I don't consider a big problem, but it would be a nice to have. And the Gateway API supports this. Then another bigger problem, I think, is it's not modular. So everything is inside this ingress controller. And this makes it quite large if you have many applications. It's also getting hard to figure out what's going on if something doesn't work. And it would be nice if you can split it up in different applications, if you can set different permissions, but unfortunately, that's not possible with ingress. And the result of this is that you don't really have a separation of concerns. So if you have multiple teams, then it would be nice if each team could manage their own ingress component, or if you have an operations team that they manage certain parts of ingress and the development teams manage other parts. That's not possible, and everything has to be managed by one team. All these problems should be solved with the Gateway API. So the Gateway API has gone to GA in 2023, and it took all the learnings from ingress and tried to improve upon them. So I think you can call the Gateway API kind of the ingress version 2. And now let's take a look how this Gateway API works. So the biggest change is that all the components are modular and they're split into multiple parts. So they took this one big ingress object and split it in different parts. And this makes it way easier to understand how it works. And also, if something doesn't work, to figure out where to start looking. Then something I haven't mentioned before with the ingress, with an ingress class, this configures which ingress controller we use. And we have the same in the gateway. That's called a gateway class. And there we also tell our gateway what controller to use. So you're going to see this later in the demo. But what's great about this is that it's using a standard. It's not using an annotation. And so we can configure the gateway to use this gateway class. And this tells the gateway what application it should use to process the requests. And here you can see how this works. So we are going to define this object of gateway class. Then we provide a name. In my case, I'm using Envoy as my gateway controller. Therefore, I use the name Envoy. And then you configure the controller name. This is something you look up from the documentation, and then you paste it there. In my case, I'm using Envoy proxy. Therefore, I have the Envoy proxy configuration there. If you're using Nginx or Traffic, then you also look it up and paste it there. And this is the only thing you have to change if you want to change your controller. So let's say I want to move to Nginx. I look up the controller name. I change it here in the gateway class. I redeploy the gateway class, and that's it. I don't have to touch any of my applications, and everything will work from then on. Here you can also see how a request goes from the user to our application and what objects with the Gateway API are used. So if you send a request, in this case, https example.com, then our DNS record points to the public IP of our gateway. This gateway has a gateway class attached. This means the gateway knows what controller it should use to process the request. but the gateway also has the TLS certificate attached. This means the gateway can verify the HTTPS connection, and if everything is in order, then it has a root object attached, and this root object is listening on the URL. So for example, if root object for example.com, this means the request is forwarded to this root object, or this root object configures how this request is forwarded in general, and this root object configures what service should be used. And with this, the request is forwarded from the gateway to the service, and then from the service to one of the pods, and the pods serve our application, and the user is happy. Then the main component, as we just saw, is the gateway, and the gateway contains all the listeners. This means we have a section of listener, and there we define on what ports we are listening, what URLs, what protocols, and if it's not in there, then our gateway is not processing the request. These listeners also have a link to the TLS certificate. So for example, if I have a listener on port 443 for HTTPS, I say the URL is example.com, and then I have a link to my secret where I will store the TLS certificate. Then a really great advantage about the gateway is it's namespaced. This means I can deploy a gateway in a namespace, and then I can configure, do I accept all requests from everywhere or only from my namespace. So in theory, I could have a gateway per namespace if you want to have it completely separated from each other, which is probably not the best idea because it's a lot of management work, but it would also allow you to have multiple gateways. For example, if you have a test and a prod environment inside your cluster, you can separate this. Or if you want to use different gateway controller, for example, one for Envoy, one for Nginx, then you just have different gateways and they reference a different gateway class. As I just said, these gateways consume the gateway class, and what's important is that this gateway class is global. This means you only have to configure it once. In my example, I can configure the Envoy gateway class, and then no matter how many gateways I have, they can all reuse this gateway class. And here we have the configuration of one of these gateways. It's a Kubernetes object of type gateway. Then we provide a couple basic information like the name and the namespace you want to deploy it. Then we have one annotation with the name of the cluster issuer. The cluster issuer is a part of the cert manager and will allow us to automatically create the TLS certificates. So that's what we're going to take a look next week. Then we have a reference to our gateway class. So that's the name we have configured before. And that's the only thing we have to change if you want to change the gateway controller. So you would create a new gateway class, have a new name, for example, Nginx, and then we change it in this gateway. And then we have listeners. Here in our case, we have one listener on port 80 for HTTP, and it allows routes from all namespaces. This means I have this one central gateway, and all applications can use routes to have the traffic routed to them. Then we have a second listener, this time on port 443 for HTTPS. Then we are going to configure one host name, in this case demo.program.wolfgang.com, and a link to a TLS certificate. To be more specific, to a secret, because the TLS certificate will be stored inside the secret. And because we added the name of the cluster issuer before and have here this link to this TLS secret, the cert manager will register this and will automatically create the TLS certificate for us. So that's already everything we have to configure for the TLS certificate. So now let's take a look at the routing. So far we have our gateway that knows what controller it should use to process the request. Now we have to figure out how to get our request from the gateway to the actual application. And what we've seen is in the gateway, we can have listeners on different ports. So for example, we're using port 80 and 443, but we can also use different protocols. So we have seen HTTP and HTTPS, but we can also use TLS, TCP, and UDP, and then use the ports that are associated with these protocols. And once we have these listeners, we have a root object. And this root object can configure whatever we need for the routing. And one option would be weighted load balancing, or it's also called traffic splitting. And there we can send our requests to different services. This could happen at random. For example, if you want to do A/B testing or canary deployments, I think I have a screenshot in a minute. But this is used if you want to test something. For example, with canary deployments, I have a new version, I deploy it, and then I send 1% of my users to the new version. If everything works, then I send 3% or 5%. And if it still works, I increase it until all users are switched to the new version. If something shows up on my monitoring, I just change it back and send everything to the old version. And this allows me to have my blast radius as small as possible. For example, if I send the 1% to the new version, something doesn't work, then only 1% of my users is impacted. Then with the roots, as everywhere, the gateway API is using standards and not annotations. This means I don't have to change anything. If I change the controller, everything will stay the same. And with the roots, we have different objects depending on the protocol you're using. So we have a root object for HTTPS and HTTP. So this would be a HTTP route. But we also have the same for TCP and UDP, for gRPC and TLS. And here you can see the HTTP route object. That's the one you're probably using the most. And it configures everything we need to get our request from the gateway to one of the services. So the type, HTTP route. Then we have a reference to our gateway. So here we have the name of the gateway and the namespace where it's deployed. This is important because this HTTP route, as you can see up here, is deployed in a different namespace. And with the name and namespace, it knows exactly where to find the right gateway. Then we have the same URL configured as the listener in the gateway. And then we have a couple of rules. In this case, we just have one rule, and we send all our requests to a backend with the name traffic on port 80. And this was the last puzzle piece we need to process our request. So our request lands at the gateway. The gateway has this listener, and then this HTTP route is connected to the listener and then configures that the request should be forwarded to the service of my application. And from then on, we just have Kubernetes logic, where the service does the load balancing to the pods. So far, we just sent the basic, sent everything to the service. So that's not even basic routing, I would say. That's just forwarding. But we've many different options for our routing. So the simplest one would be with path. As said before, we can have, for example, an online shop. And if I have /path, /admin in my path, I send it to a different application. Then we can also route based on the header. Commonly used is the user agent. So if I'm on a desktop, I get the desktop version of my online shop. If I'm on a smartphone, I get the mobile version of my online shop. And these are two different applications. Then I can also use the query parameter. Something I personally don't use that often, but I can see that maybe you want to check up with a cache and use the routing this way. And then we can also do routing based on the HTTP method. This can be useful if you have heavy operations. For example, if you have a video service and uploading a video takes way more resources than maybe just watching a video. So you can separate the upload and the watch service, and then you route based on the HTTP method. And lastly, we also have a redirect and rewrite of the URL. So redirect can be very useful if you have, for example, an old version of your URL structure and you change to something new. But you have all the marketing for your online shop out there from the last 10 years, and you don't want to have all the users receiving 404 error. So you can have this redirect option, and you say if it's sent to the old URL, redirect it to the new URL. And this allows you to be backwards compatible. Here we have a screenshot of one of the rules where we have the weighted load balancing. So in this case, we have two backend references. One is for the app number 1. It has a weight of 20. This means we send 20% of our requests to the app number 1. And then we have the service with the name app 2 and the weight 80. This means we send 80% of our requests to the app number 2. We're going to see this later in the demo. But if you want to change this and you say something didn't work in the app 1, then you can change the weight to 0 and send all the requests to the app number 2. What's important is that the weight, the number, is in relation to each other. So if I have 80-20, it's the same as 8 and 2. And a rule of thumb would be to use numbers below 1,000. I could use 2 million and 8 million. It's still the same, but it's just harder to read. And here we have a couple screenshots for more rules. I'm also going to show you everything in the demo later. But the first one is with the path prefix. And this rule applies if my path starts with /my/path. So for example, if I have example.com/my/path/abc, then this rule applies. Then in the next section, I have a filter. So if the rule applied, now I say what I'm going to do. In this case, I do a URL rewrite and I replace the full path. So it doesn't matter what's in your path. As long as it starts with /my/path, I'm going to replace everything with /replaced. And then I send it to the service of the name app1. Then I have a second backend reference, and this is a catch-all rule. So if none of my rules from before matched, then I send it to the service with the name app2. If I don't have this catch-all service there and no rule matches, then my request won't be processed and our user gets an error message. So now let's take a look at the gateway API versus the ingress. So far, I might have sounded very negative against the ingress. So I basically only talked about all the downsides of ingress and how great the gateway API is. But in reality, that's not entirely true. Because if the ingress is working for you and you're happy with it, there's no reason to replace it with the gateway API. This means if you replace it, it might be a lot of work to get it replaced. And the question is, do you get any features you don't have yet with the ingress? So therefore, I've believed that the ingress will just continue being used. And especially if you have a small team or not that much knowledge about it. If you got started with ingress once, it works, then you might just reuse it the next time you need it again. And this is especially true if you have a small team. If I have like 2 or 3 teams that use one ingress controller, the configuration doesn't get too large. I still know what's going on, and so I just might need it or use it. If you have a large cluster and you have different teams, especially if you have a split between operations and development, then the gateway API might be very useful for you, because thanks to the modularity, I can have a real separation of concerns. I can have my objects in different namespaces, and so it's clear who matches what. Maybe one last sentence. My own opinion is, if you're using ingress right now and you're happy with it, you don't have any requirements that can't be fulfilled, continue using ingress. If you start a new cluster, I would look into the gateway API, because in my opinion, it's so much easier to manage. It's extensible. This means if you have in the future more and more applications, you just add new objects, and you don't have to add everything inside this ingress object, and you make your life easier. Now let's take a look at the gateway controller before I start with our demo. The gateway API has been out for not even 3 years, and therefore the ecosystem is not as large as for Ingress, but the most common or most popular vendors all have their own solution. So for example, with Nginx, we have the gateway API that's called Nginx Gateway Fabric. Then we also have Traffic, then Envoy Gateway. That's my personal favorite and what we're going to use today. And if using a cloud provider, then in Azure, we have the Azure Application Gateway for containers. And before I take a look at demo, let's quickly talk about the Application Gateway for containers. So this is an add-on for AKS. So you can either install it by hand, which involves quite some steps, or you can just enable this add-on. That's a one-line command, and it will install everything you need. This feature is in preview right now. It usually works, but sometimes it doesn't install it correctly. So you would have to uninstall it and then reinstall it, and then it should work. And what's great about this is it runs outside your cluster. This means all the processing is outside your cluster. This means you need less resources in your AKS cluster. Therefore, your AKS cluster might be cheaper. And it brings additional features like advanced health checks, so you can do more than what you can do with Kubernetes natively. You have the WAF support, that's the web application firewall. And that's really cool because you can attach it to the gateway, but you can also attach it to all listeners or to paths of the gateway. So for example, if you go back to the online shop, I can have my normal online shop where I allow basically everything except maybe countries that are not the greatest, or they don't have the greatest reputation. But if I have /admin for my backend, I only allow IP addresses from my corporate network. So I have the special protection for the admin area. Then I have more monitoring. With Azure, we have the integrated Prometheus and Grafana. So we have out-of-the-box dashboards. Everything is integrated with managed identities. I don't need to set up anything. Everything will be set up automatically once I enabled it. And since it's an Azure service, it has all the Azure features like auto-scaling and high availability. The downside is I have to pay for it, kind of obviously since it's an Azure service, and I have more complexity because if something is not working, then I have to figure out, is it in my cluster or is it outside the cluster? And my recommendation would be, especially when you get started, use one of the open source provider like Envoy or Nginx, because you take a lot of complexity out of the whole process. One last slide about how the application gateway for containers works. So what you do is when you install the add-on, you install this ALB controller. That's the application load balancer. And this has a link to the Azure Resource Manager. So that's the API that creates Azure services. And once you've set this up, then the ALB can deploy over this Azure Resource Manager the application gateway for containers. This means you don't create the application gateway. It will be created by the ALB controller. And the ALB controller also takes care of the configuration. This means it configures it with the right gateway class, and everything you need to have the gateway working. But again, this makes it a bit more complicated, especially when you just get started with the gateway API. So it's a lot going on. And now let's take a look at the demo. And I want to show you everything I just talked about. So let's switch over to our terminal. And let's define a couple variables. So here we have 3 variables for our AKS cluster. That's the name, the location, and the resource group. Then we have 3 variables for our gateway. So that's namespace where we're going to deploy it in, the name of our gateway, and the name of our gateway class. And then 4 variables for our demo application. So we have namespace for our demo application, then 2 different names, and the URL we are going to use today. Then we're going to create a new resource group where we're going to deploy everything inside. And once this has been created, we can create our AKS cluster. So just AC AKS create the name and the resource group, and the cluster will be created. I did this already before because it takes between 5 and 10 minutes, and I don't want you to wait. But if you download the code, you can just execute it and you'll have your AKS cluster running. So once we have our cluster, we can download the credentials, and then we can access our cluster thanks to these credentials. So now we can get started with deploying our gateway controller. As I said, I'm using Envoy. It's, in my opinion, the easiest to install. And as you can see, we use Helm install. Then I set the version. You don't have to do this, but I like to know what version I deploy. Version 1.8.0 is the newest as of today. Then we configure the namespace we want to deploy it. We tell it to create this namespace. And then we also set the replicas to 3. This means we're going to have 3 pods of our Envoy proxy running. You don't have to do this for the demo, but I just want to show you, if you're new to Helm, how you can configure more configurations of the application you deploy. And that's it already. So our Envoy proxy now has been deployed, and we have 3 replicas running. Then what I said before, we have the gateway and the gateway class node. So now let's take a look at our gateway. And I'm just going to get all gateways with the -A from all namespaces. And what we can see here is we don't have one. If we take a look at the gateway class, here we don't need a namespace because the gateway class is a global object. Then we can also see we don't have one. And here depends on the vendor you're using. I think Nginx creates them already. So you already have a gateway and a gateway class. Envoy doesn't. This means we have to create it ourselves. So that's what we're going to do next. So here we have our gateway class. So that's basically the same you have seen in the screenshot before. With the type gateway class, we provide our name, and we have the controller name for Envoy. And I also like to have it this way because I'm using PowerShell. If you're using Linux, you would use the EUF command. But I think for the demos, it's easier if I don't have everything in a file and then open 10 different files. So it might be easier to follow. In a real-world deployment, you usually have this in different files. But now we can apply this. And this creates our gateway class. So with this, we can now paste our gateway. And here you can see we have the type gateway. We have a name and a namespace. Then we have here the link to our cluster issuer. That's something we're going to take a look next week. Then we have here our reference to the gateway class we just created. And then we have our listeners. In this case, we only have one listener that's listening on port 80, which is HTTP. And it's listening for the demo URL. So that's the demo.programwithwolfgang.com. And it allows roots from all namespaces. This means we can deploy our demo application in a different namespace than the gateways, and it will be able to use this HTTP route object we're deploying then. Then we're going to apply this. And this sometimes takes a couple minutes until it's applied, but let's take a look with kubectl get gateway what's going on. And here you can see everything is already set up. So we have the name of a gateway, we have the class, we have a public IP address, and we have this program state to true. If it's not ready yet, then this program is set to false. This can happen, for example, if it takes longer for Azure to assign a public IP address, or also if you made a typo or misconfigured something. For example, if I have a typo here and have 2by at Envoy, then it can't find the class name with Envoy with the 2by, and then this program state would be false. So this is the first indication that we set up everything correctly. Then we can also describe this gateway. So if something is not working, then this program state would be false. And now you can take a look inside this gateway with kubectl describe gateway. We provide the name and the namespace. And there you can see everything that's going on with our gateway. So if we scroll up a bit, we can see the annotations. We have here the public IP address with our listener. And here we also have everything that's going on with the status changes. But as you can see here, we have accepted, we have true, we don't have any error messages. The listener reference have been resolved. So everything is fine. If you misconfigured something, you should find it in there. And lastly, we can take a look at our gateway class with kubectl get gateway class. Since we created one, we now get one. And here we also have the name, the controller we configured before, and also accepted is set to true. So this also looks everything correct. And now we can use it. So next, we are going to use our public IP address and configure our DNS so we can have the URL demo.programwolfgang.com pointing to this public IP. And since I forgot to copy it, we can also query it with the kubectl get gateway, and then you can find it under this path. So here we have the public IP address. I'm going to copy it, then switch over to the Azure portal. And here I have my DNS zone for programwolfgang.com. And I've already prepared a couple entries. So here I have the demo one, and that's an old IP address. So we're going to change this one with the new IP address. If you set this up the first time, all you have to do is create an e-record and you paste your IP address there. And that's already it. So now our DNS, demo.programwolfgang.com, points to the public IP address of the gateway. This means we can go back to our gateway. And now we can deploy our test application. So let me just paste the code, and then we're going to take a quick look what we are deploying here. So this is as simple as possible of an application. So first we create a new namespace, and then we deploy everything inside this namespace. This means we have one deployment with one replica. And as my container, I'm using the traffic who am I. I like this because it gives you just some basic information. For example, what pod is serving the request. It's a small image, so it's downloaded quickly and it starts quickly. Lastly, we have our service. What's important is we have the type cluster IP because we don't want it to be accessible from the outside. We want it only to be accessible through the gateway API. We configure the name and then the ports. So our service is listening on port 80 and the demo application is also listening on port 80. Then we're going to apply this. So this now creates all these resources. And then we're going to deploy our second demo application, which is basically exactly the same, except we have here a different name. So instead of demo app name 1, we have demo app name 2. This also shows how creative I am with my namings. And this also deploys the service and the deployment. So it should only take a couple seconds. And now I can do a kubectl get all inside this new namespace. And everything should be up and running. So you can see our two deployments are running. Our two services are both of cluster IP. This means we have no external IP because we go through the gateway, and both our pods are running. And with the pods, we can see the first one is named demo1 and the second one is called demo2. And once we test them, we can see what pod is responding. So the last step or connection we need is the HTTP route. This means so far we have our DNS pointing to the gateway, and we have our demo application, and now we just have to link them. And we're going to do this with this HTTP route object. Then we're going to deploy it in our demo namespace. This means it's in the same namespace as our application. And that's great because the developers can create this HTTP route because they know best what ports, what names they have for their service. And all of this works because we have this reference to the gateway. So we have the name and the namespace of the gateway. Then we also have the URL. And here we configure, we send everything to the service with the name demo app name1. Then if we apply this, and now it usually takes only 1 to 2 seconds and it will already work. So now let's test this. We can do a basic curl to the demo URL. And there you can see the host name is the demo1 container. If you scroll a bit up, we can see here with HTTP 200. So everything is great. And this also proves we were able to access our application through the gateway API, and thanks to the HTTP route and the service. And we got our request served to the right pod, and we also received an answer. All right, that's great. So our application is accessible. This might be good enough for very basic applications, but in a corporate environment, you usually have more you have to configure. And now let's take a look at a couple of the routing options. Everything is configured in the HTTP route. Therefore, I'm pasting here again. It's the same HTTP route as before. This means I just overwrite it. So we have the same name here, the same gateway, the same URL. But this time we have a couple of rules. And here we have two rules. The first rule is for the path. This means if our path starts with /routing, then this route is true. This means /routing /abc, and it would be true. And with a second rule, with the type exact and the value /exact. This means only if our path is /exact, then this rule is true. If it's /exact /abc, then it is not true. And if one of these two is true, then it is sent to the service with the name demo app name1. If none of these rules are true, then it is sent to the demo app number 2. So we're going to apply this, and then we can test different requests, and we can see who responds to the request. So first, we just have a very basic or normal URL. And if you take a look here, the demo number 2 replied because we don't have anything in the path, so none of the rules was true. If you do the same request, but this time with /exact, now we expect to be one of the rules to be true and the demo app number 1 responding. And here you can see demo 1 responded. But if you do the same with /exact /abc, now the demo number 2 should respond again because it's not exactly /exact. It's more than that. Therefore, the rule is false. And here you can see number 2 has responded again. And lastly, to test also the other rule, we have /routing /abc. And here the demo number 1 replied because we had in our path /routing. Therefore, the first rule was true. There's a lot more to the routing, and you can play around with it all day. You can configure the most complicated stuff. For example, you can use regex. You can have routing based on the path and the query and the header. So I think for the start, it's good enough. The last thing I want to show you is how we can do the weighted routing. So here again, we have our HTTP route. And under our rules, we have this time 2 backend references. first the number 1 with a weight of 20, and then the number 2 with a weight of 80. This means 80% of the requests are sent to the number 2, and 20% are sent to the app number 1. So I'm going to apply this. Now I'm going to switch over to Linux, because there you can use the watch command, which is easier to send just continuous requests. I configure my demo URL, and now I send this request. And with the watch -n, this means I send a request every second, and now I can see who is responding. Here you can see it's demo 2, and there's demo 1, and it's going back to demo 2 because it's 80% demo 2 responding. And there's demo 1 again, and so we can see it's approximately 80%, and over time it will balance it out to be exactly 80-20. What I could do now is I can change this on the fly. So I can change, for example, to 50-50. Then I reapply the same file. So you can see here I have 50-50. I apply this. And if I go back to the request that I accidentally stopped, now you can see we have 50-50 response. So it's demo 1, demo 2, and it's sometimes 2 goes to 1, and so on. But overall, you can see it has changed from mostly 2 to around both the same. And I think that's very powerful, because you can make on-the-fly changes with only this one deployment. So if something goes wrong, you deploy your HTTP route, and it should fix the problem. And that's everything I want to show you today. So again, if you're interested in the slides or the code examples, you can scan the QR code and download them from my GitHub repository. And I hope it was useful for you to get an overview of the Gateway API, of its advantages, how it compares to Ingress, and hopefully you're interested now trying it out. Next week, we're going to build up on this. So now we have the foundation for the Gateway API, and next week we're using the Cert Manager to create TLS certificates. This means we can extend our gateway to use HTTPS and also use wildcards.
I'm looking forward to that. It's going to be a good session. I might need double coffee for Cert Manager, but yeah, thank you very much for coming and presenting to us today. I've been monitoring the chat throughout. There's no questions. I think hopefully you're answering everyone's problems, but as I put in the chat, and for those watching the recording, feel free to reach out to Wolfgang, ask him questions, connect on social media. That was great. Thank you very much. I like how you went through, explaining the concepts and then the demo. What was really refreshing actually was seeing the PowerShell. Like it's not many people use the old-fashioned PowerShell terminal as much these days. So it was really refreshing to see that being brought up instead of just Linux from the get-go. So thank you very much for doing that. Yeah, brings back some memories from last year.
Yeah, thanks for having me. I'm also excited about the Cert Manager. It's one of my favorite tools because it takes only like 2-3 minutes, and we have TLS certificates that are fully production ready. The browser's not going to complain. And if you're old enough, you know how it was back in the days. Something didn't work, you had to buy it, you had to install it. It was such a hassle. And now I paste like one file and it's everything automated. So yeah, it's amazing.
Yeah, they've made a lot of great changes with Gatekeeper and stuff like that as well. So, but there's been a lot of change, primarily, especially with Kubernetes Ingress lately, with some of the stuff going out of support as well. So thank you very much for presenting to us today. I will bring up the thank you slide, but yeah, there's no more questions in the chat, so I think we'll leave it. But thank you for dedicating some time to us today. Thank you.
Yeah, thanks for hosting. Thanks for everyone joining. If you have any questions, feel free to reach out on LinkedIn is the best way, or next week. We're going to have some time, I guess, for questions again.
100%. Join us next week. Thank you.